Number 6. This is coordinate geometry, right? Okay, so I have some circle, and it looks like the center of the circle, right, is down here. They call that A. And I think what we want to understand is, we're actually going to start working with this more and more. From here to here is the radius of the circle, okay? What they told me is that this is where we're starting to look at, today we're going to be introducing that on a coordinate plane, if you want the distance between 2 points, you're going to use the Pythagorean theorem. In algebra, they give it a fancy name. They call it the distance formula. It's just the Pythagorean theorem. That's all it is, right? Even though they call it a separate formula. But if you notice, the radius is the hypotenuse of a right triangle. So if you can figure out 2 of the 3 parts, you can find the 3rd part. So what they did is they told me that this was 7, positive 7, negative 1. This is my x, this is my y. They told me that this one is 11, negative 4. This is my x, this is my y. The easiest way to think about this to me is, how much did x change? That's my horizontal distance. Well, x went from 7 to 11. How much did it change? 4 units. I don't even have to do any fancy formulas here. How much did y change? Went from negative 1 to negative 4. It went down 3, right? Do I need to pull out the Pythagorean theorem to know what the radius of the circle is? It's a 3, 4, 5 triangle. The radius is 5. We are using this math all the time in my trigonometry class, okay? If you know this, you don't have to do any calculations. You don't even have to think about it, okay? This is a 9.5 concept as well, okay? All right? So we're given coordinates, we're given distances, okay? So, page 368.
Number 3 is intimidating just because of all the words.
Yeah, it's all the words. Okay, it's figuring out. Remember I told you, you got to figure out how to draw the triangle, right? So you got to find a triangle. I did give you a little hint in the last class that whenever you do these kinds of triangles, you have to keep north, south, east, west. This is something that gets used enough that you want to know those orientations, right? And so in my key, I simply diagrammed it. Meteorologist Paul Windward and geologist Raina Stone are rushing to a paleontology conference in Pecos Gulch. So with the wind blowing west to east, wait a minute, I missed a line, didn't I? Paul lifts off his balloon at noon from Lost Wages. Right, so Paul is at Lost Wages, aka Las Vegas, and he goes east. Okay, so he goes due east. And again, I'm using this here. So he goes due east, and he averages a speed of, he's going 30 kilometers, not miles, 30 kilometers per 1 mile. Per 1 hour. This will allow him to arrive in 4 hours. Okay, if he is going 30 kilometers per hour, how far away, if he drove for 4 hours, how far away is this distance?
120.
It's going to be 30 times 4 hours, right? It's going to equal 120 kilometers, okay, to get to Pecos Gulch, okay? I'm just already thinking, if I've got a rate, I've got a time that gives me a distance. Anybody, you guys have heard of DIRT, right? Distance is equal to rate times time. Okay. So we also have Raina. She is 160 kilometers north of Lost Wages. So Raina is she is starting up here, right? Okay. She is north of Lost Wages. 160 kilometers. Does anybody see where we're going with this? It's going to be a 3. It's going to be 12, 16, right? And she hops on her off-road vehicle and heads directly for the conference center. Okay, so Raina's up here, and she's going this direction. Okay, so At what average speed must she travel in order to arrive at the same time that Paul does? Well, they didn't just ask me for the distance, but to get a rate, I need time and if I have distance, I'm using a distance is equal to the rate times the time. Again, we're using this all the time, science classes, etc. So, using the 3, 4, 5 triangles, this is
200.
yeah, this is good. So the reason we're recognizing this is, first of all, I could cancel the zeros, right? This I could say that this is 3 times 40, right? This is 4 times 40, so this has to be 5 times 40. If you did not recognize that, you could have cranked this through your calculator, and your calculator would spit out at 200, right to you? Okay? And again, that's a right angle, so we're going due east, due north. Now, it said she started out at the same time that he did. How much time did he take to get there? 4 hours. If she started out the same time as he did,
Took 5 hours.
right? No, she's going to take the same time. What we're finding is the rate. We know the distance. I'm thinking, is that what the question asked me? Is how fast would she have to travel?
Yeah.
We know the distance. We don't know the rate, but we do know the time, 4 hours. The rate has to be,
5.
yeah, divide 50. Yeah. So she has to go 50 kilometers per hour in order to arrive at the same time as he does. If she's off-roading it and she doesn't have to go on roads and stoplights, she could probably go faster than him anyway, right? Good problem, actually. It's not that hard to solve, but interpreting all the words and setting it up does take a little bit of work, okay? And again, it's fine if you came in not knowing as much as everybody else. Over the course of a semester, I've usually found people catch up an awful lot. Sometimes you learn something better sometimes when you have to use it than if you were just learning a skill independently of itself. So, anything on 361 or 362? Oftentimes what is helpful is talking strategies. The more complicated the problems become, the more possibilities you have, right, in terms of how to approach it, and some involve more work than others, right? Okay? Let me just be very clear about some of the skills that you do need to have. Let's go, I'm going to take number 18, okay? The square root of 11 over 44. Simplify to what?
1/4.
Yeah, so what I would do is, if I could, I would simplify the fraction inside. I would not take the square root of 11 over the square root of 44. I'd eventually get there, but it would be a lot of work. Now, sometimes if I simplify the fraction, I could actually create more work if I was saying eliminating a perfect square, right? Okay, but in this case, now I'm just taking the square root of 1 on top. So notice we can split them up, right? The square root of 1 over the square root of 4 becomes square root of 1 is 1, square root of 4 is 2. Okay? All right? So remembering that I can mush them together or I could split them up, whichever's going to make my life the easiest, right, is going to be what I'm going to work on there. Okay? What about something like number 20? This one's not going to come out quite so easily. But again, this one here, I would look at it this way because that is a perfect square. So this one, I obviously can't simplify it anyway, right? So I'd get the 5 comes out on the bottom, easy enough.
And then you'd have 4 and 3.
Yeah.
Times 4.
This is the square root of 4 times 3. The 4 comes out, and you will always see me factor out the perfect square in front because it's what's going to come out, and I'm never going to factor out a 6 or a 10. Why?
It's not perfect.
They're not perfect squares. It doesn't help me to factor anything other than a perfect square under a square root. Nothing else, well, that's not to say nothing else will help me. If I have a number and another number, I can find a square. I'm finding, look, it's always a hunt for a perfect square under a square root, right? Okay. What's the issue with number 22? Why is that not going to be able to stay the way it is?
The bottom is irrational.
Yeah, so I just did a problem yesterday in my trig class where I had an answer that looked like this. We don't move that. That stays where it's at. It's complicated. There's no reason. We're not going to try to rationalize and put that up there. But if these are numbers that I can deal with, okay?
Isn't that just the difference in squares?
Huh?
Yeah.
Isn't that just the difference in
It comes from this that I have. If I have something like this, right triangle, using the Pythagorean theorem, I'm going to come up with this. And you've read, yeah, so that's where that comes from when we start working with those kinds of situations. But I go off on more tangents in your class than any other class I've had. The square root of 5 over the square root of 7. I'm going to keep us on track here. It's all right. I enjoy it, by the way. I enjoy some of our little psych, but I have to keep this one under control today. This one out here, I need to get the root 7 to become
So 7.
a 7. How do I do that? By multiplying by so by squaring a square root, the strategy is that comes out as a 7, but I can't just multiply the bottom. I have to multiply the top, right? Okay. And then what do I do with this?
You get root 35.
I get root 35. And how do I know I'm done? That there's no perfect squares in 35, right? It's 5 times 7, no perfect squares. This one is done, okay? Number 24, I'd have to push the root 2 up, right? When I push, we are actually working problems. This, number 24, is exactly what happens if I have one of these situations. Do you remember?
Oh.
This is exactly what's going on here, right? Okay. So this is why. Remember that whatever this is the leg times the square root of 2, right? This is isosceles right triangle, which means the leg has to be 8 divided by the square root of 2, but you cannot leave it like that, okay? Right? I have to multiply top and bottom by, so I'm going to get 8 root 2 over 2. Oh, 2 goes into 8. I'm going to get 4 root 2. And you will notice this pattern that if that is an even number, when I rationalize, I'm going to get a 2. I'm going to end up losing my fraction. And on the 3-ish triangle, the 30, 60, 90, if I have a multiple of 3 there, the 3 will go away in the fraction. But you don't have to memorize that pattern, but usually you start noticing it. Okay? But that's what we're doing here. So that number is exactly like what happens when we do one of those. Then something like number 26, how would I clean that one up?
8, 16, 3.
Okay, wait a minute. Okay, I have a question for you. Would I automatically take the square root of 16 and turn that into a 4?
No.
I'm not going to do that. Right, okay, so notice, use some strategy here, because what I do notice is there's an 8 in the other one. So I'm just going to mush them all together and see if I can't simplify things, right? Okay? Can I do some simplifying here? I can do a lot of simplifying here, right? 3 goes into 15 rather, 5 times, right? Okay. 8 goes into 16, 2 times. Okay. So this whole thing simplified to the square root of 2 over 5. If I separate that out, split that up though, what do I get? I'm going to get a root 5 in the bottom, right? So you could do one of two things. I could write this as the square root of 2 over the square root of 5 times the square root of 5 over the square root of 5 is equal to the square root of 10 over 5. Did I do that right?
Yes.
Okay, all right. Could do all that, or I could notice something. What happens if I just make that a square? I could do it under my root, just like that. It saves me having to do all this writing, right? Okay? In other words, if I already know I'm going to have to pull that out,
Then get 2.
then I'm gonna get, notice I'm gonna get the square root of 5 squared will be a 5. I'm gonna get the square root of 10 directly. So hopefully you're all feeling at least a little bit more comfortable working with these, right? Okay. And then on the second page, those had the variables. I had done some of those in class. Anything on there that anybody would like me to go over on page 362. If I have something like, if you look at number 47, 2 over the square root of x, do I handle that any differently than if it was over the square root of 5? No, I'm going to multiply by the square root of x over the square root of x. I'm going to get 2 root x over x, right? 371, this one was not assigned for homework because I did these problems in class, but I did want to mention that I find this class is hilarious because I put out that challenge that number 5 is a problem that I solved using algebra, and I had I never really thought about, or I'd always challenge students to come up with an easier way to do it. And then at the end of class, Viv was, you were thinking it was a way to get there with angles, and we were going back and forth.
Yeah.
And
But then later.
it's a little bit tricky in that it looks like there's these special triangles, but it turned out that it was the wrong way around. But what I find utterly hilarious about this is I would have seen a solution that was way easier if the author of these had not drawn extra unnecessary lines. And this is a comment about not drawing more line, taking a moment to look at a problem. So watch. And then we have this going through the circle, okay? And they drew a radius, right? Okay? But if you knew that this segment here is 6, if you knew that this segment here is 4, this is obviously not to scale. And this is 2 here, right?
Then we gave you the right angle with the tangents.
Yeah, okay, because this is a right angle, that's one thing, because it's a tangent. There's the other thing is that if that is 6, that is 6. And that's because I focused on the radius over here. And there's a way to do it. I can show you guys. It's actually not terribly difficult, but it's about 6 steps more than what we're going to do this way, right? So if this is 6 centimeters,
6 and 10.
yeah, this is 10 here, right? Right triangle, 6, 8, 10, not to scale, obviously. If this whole thing is 8, and that was 2, what's the diameter? 6. What's the radius?
3.
The radius is equal to 3. And there you go.
So it's 9 pi.
9 pi is the final answer. Then you go back to make sure you're answering the question.
Yeah, I went to the corrections after I was like,
Okay, the way that I did it is not, let's just put it this way. It's the way that my brain went because I wasn't looking at this side. I was looking at the fact that they drew a radius in, right? And so there's a radius and there's a radius. And what I did is I just did something that you had already been doing, which is solve the right triangle using the Pythagorean theorem, which is really a systems of equations, what it is, right? Two things that are true about the triangle are equal to another thing that's true about the triangle. And so just to understand that because I just used this little triangle here, that this, I'm going to kind of draw it out. If this is a radius, right, and this is the radius plus 2, and this is a 4, well, huh?
the radius would have to be.
Yeah, well, it's not completely obvious. You could guess it, right? But you could say, well, the radius squared plus 4 squared is equal to the radius squared plus 4r plus 4. I'm squaring that binomial. And then you can solve, this goes away. I've got 16 is equal to 4 times r plus 4. Minus 4, 12 is equal to 4r, r is equal to 3. So you don't even need a quadratic, equation solving skill. You just need to know how to expand, okay? So 2 different ways to do it. I did it that way because I saw 2 radii, but it turns out that this was actually the easier way to notice the tangent. So that's why I pulled that out. Pardon?
They probably do the lines that it's a kite. Or
Yeah.
if you're
Yeah.
gonna be a kite,
Yeah.
doesn't help them.
Because that's how you find it's right. It's
Well,
not the
yeah, if you're
center.
thinking the kite,
Then-
I just was looking on the right, and not only that, but probably at the time I did it, we were doing those, solving those triangles with the Pythagorean theorem, like, oh, okay, just solve the problem. So, but again, that's more work than the other way, right? If you can recognize that. All right, so I bring that up. And then I do want to mention, the other problem on that page, be careful. It is number 6. Is that a special triangle situation? It's really easy to make this mistake. Super easy. I've done it in the solutions and had to fix it myself. So if I want the area of a circle, I need the radius. And a way to get the radius would be to get the diameter, which is this. And this would be 2 of those diameters. They did tell me that that is 10.
So,
I have a 1 to 2 ratio in one of my special triangles. Is that it?
well, the diameter is just 5. You can do it above it. Wait.
Can I use special triangles to solve for D is what I'm trying to say.
Is it a rectangle?
Yeah.
Whole thing?
Oh,
Okay,
yeah.
so then, yeah.
No, I can't.
No.
This is the imposter. The 2D would have to be here to use a special triangle.
No, but you
Happens
have
all
AB as
the
10.
time.
Yeah.
You have the base.
But
So
I
that's
have to
2.
use the Pythagorean theorem is my point. I can't use the special triangle. Remember, okay, you have 2 special triangles, right? The one that has the 2 to 1 ratio, leg, is this one because it is half of an equilateral triangle. That's how you remember that whatever the little leg is, it's the hypotenuse that's twice the leg, not the spine, not the altitude. This is a case of the 2 to 1 ratio is in the wrong place, okay? So just be careful. When you see 2 to 1, it's not always going to be a special triangle. Does everybody see that? Really easy to jump to what would be the common thing to say? Oh, that's D root 3 is equal to 10. Solve for D. It will be wrong. Okay? All right? So I'm going to let you guys work the rest of that one for a homework problem. The next question came up was 372. There were a few. With this one, okay, I actually like this question. Some of you may have already figured this out, but I like the question because this is another pattern to pay attention to, okay? And that is that whenever I have an isosceles triangle, right, I have a situation where I can just split the base and I can use the Pythagorean theorem to find the altitude. So when it comes to isosceles triangles, I only need to know the one side, right? The 2 sides, I guess you would say. So look, they said the front and back walls of an A-frame cabin are isosceles triangles, each with a base measuring 10 and the legs are 13. Right? There's your triangle, okay? 13 and 13. With these, it's isosceles, which means when I drop an altitude down the center, I know that's a 5 and a 5. What's the height? Cool. How did I know? How do you know it's 12? It's a 5, 12, 13 triangle, right? Okay? So if you know how to diagram them, then go back and make sure you're answering the question, right? I mean, there's what the diagram tells me. It says, these are meters, by the way. Nice to know if I have my units. The entire front wall is made of glass that's 1 centimeter thick, costing $120 per square meter. What did the glass for the front wall cost? Okay? So I just need to know what's the area, and to get the area, I need 1/2 of the base times the height. It's going to be 1/2 of the 12 times 10. We'll take half twice. So I'm going to get 5 times 12, I'm going to get 60 meters squared. Okay? And then if it's $120, $7,200. Glass is actually really expensive.
Yeah.
It really is actually, if you're going to want to do.
Wow.
Huh.
Good luck.
Yeah, 383. And again, usually the questions on these are just making sure you understand when the roots and radicals become a little bit more complicated, right? So to review, we have 2 special triangles that we're dealing with. One is the isosceles right. That would be something like this. Isosceles right, think of it as it's half of a square, right? So, if this is a leg, well, this leg is going to be the same as isosceles, and the hypotenuse would be the leg times the square root of 2. Notice, I don't tend to write this on an organizer, but let's just say this is the hypotenuse. We could also go backwards with this, right? This would be the hypotenuse divided by the square root of 2. And this would be the hypotenuse divided by the square root of 2, which would then be the hypotenuse times the square root of 2 over 2, because you have to push it up. That's the part that starts to get confusing, right? Okay, it's a little extra step when we divide by a square root, all right? So, you can put this with your organizer. I kind of like to just keep it simple and remember this, and just remember that if the square root of 2 isn't there, I had to divide to get it over here, right? It has to be somewhere. And the other one, so this is what we call 40. I tend to call them isosceles right. They're often called 45, 45, 90 triangles. The other special triangle is the half of the equilateral, right? Okay. These are the 30, 60, 3-ish triangles, right? Okay? Which is what tells me I've got a square root of 3. To know where to put the square root of 3, if I'm remembering it's half of an equilateral, then the little leg being here means that twice the leg has to be over here. This then is where the square root of 3 would be normally found, right? If you're given a number here without the square root of 3, that means I have to divide by that square root of 3. It's got to be somewhere, right? Okay, so using the 2 special triangles, if I look at something like number 6, okay, now this one's 2 root 6 is what they gave me. Here's where I'm just going to use equations. The leg times the square root of 2 is going to equal, so I'm just going to say this is the leg times the square root of 2. Look at it that way, right? Okay, so this one was a little bit more complicated because I'm working backwards. All I want to do, though, is I want to get rid of the square root of 2 from both sides. This is where knowing that 2 times the square root of 6 is the same as 2 times the square root of 3 times the square root of 2. I could take that 6, pull the square root of 2 out. Therefore, the leg would be divide out that square root of 2. The leg is going to be 2 times the square root of 3. Right? Okay, it's just algebra with the roots and radicals. Again, this is actually kind of another similar one in that we weren't given the square root of 3, we were given the square root of 5. So now this is going to require some algebra. Okay, we did that. There's my 60. There's my 30. So, after, it will, but what's kind of nice is if I'm remembering that the hypotenuse, if you want to, sketch out your little equilateral triangle that helps you remember that whatever that is, that's going to be half of it, right? Okay? So, because this is the base of half. So y is the easiest part. That's going to be 4 times the square root of 5. Okay, so to get this one, notice x, go back to this. it's whatever this is times the square root of 3. So it's just roots and radicals work now. It's 4 root 5 times root 3, 4 root 15. Typically, we're going to have units if these are going to be lengths, right? But for right now, we're just focusing on numbers, okay? So, yeah, lots of root and radical work in this, okay? It says find the area of A, B, C, D. What is this figure?
Trapezoid.
Huh? It is a trapezoid. Withdraw it. It is not an isosceles trapezoid. Did I make that look at least reasonably? Okay, trapezoidish. We do know, we know it's a trapezoid because we have parallel bases, right? So the way that we do these, Corbin, is we create a parallelogram and a triangle. That's the way you get these. Okay, it's a composite because what they did give me, and because we have the Pythagorean theorem, we're going to be able to do that. I think they gave me this. We call them centimeters. Yeah, centimeters. And what else? Okay, so here's how we do it. We add a line segment. Let's see here. We add a line segment here to create a parallelogram. Okay, and we know that that's a 6, right? Okay?
Yeah.
And I know that if that's 6, then this has, if I make this parallel, this has to be 22, which means this has to be 10, right? This base has to be 10.
I got this far and I didn't know what to do next.
Isn't it 3, 4, 5?
Yeah, this is a 3, 4, 5 triangle. It's a 6, 8, 10 triangle.
So you know it's right.
What that tells you is that this has to be a right angle. It's the reverse of the Pythagorean theorem, okay? So given that, can I get the area of that triangle? Yeah, it's going to be 1/2 of the base times the height. Okay, the right angle's there.
Oh, yeah.
So 1/2 of the base, huh?
So it'd be 4 times 6?
1/2 of the base is going to be 1/2 of 6. Or you could say half. It could be either 4 times 6 or 3 times 8. Either way, I'm going to get the area of this triangle is 24. So I know that the area, did they give me a letter here? Let's just call, so A, B, is this B?
Mm-hmm.
C, D, okay? So I'm going to call this E, okay? Triangle ECB, the area, right, of triangle ECB is equal to 24 units, right? Now I can get the height, working backwards. Now I can look at it this way. Yeah. This is going to equal 1/2 of the base 10 times the height. And that's how I can get the height of the trapezoid. I'm going to give you a moment to make sure you followed what I just did.
This is more work.
Yeah, I made 2
This
more
is a
lessons.
classic way of doing this. So now I know that 5 times the height is 24. So the height has to equal 24 fifths, right? Okay, or 4.8. I work in fractions until I have to work in decimals usually. So if I know that now, I can get the height is equal to, let's just say 4.8 or 24 fifths. What's the mid-segment?
27.
The average, yeah.
Well,
you're right. Yeah. So you get a 22, a 32, or 54, divide it in half. So remember, at area of a trapezoid is the mid-segment times the height. So if I get 27 times my 4.8, I'm going to get the area.
Add the area of the parallelogram.
Area.
No, you can take the area of the parallelogram and add
Plus the
a
other
triangle.
You could do that, but I'm just doing the area of the whole trapezoid. Yes, you could. I could. You're right. I could have done, I could have done this times this and added it to the 24, that would get me there. But what I'm just doing is saying, hey, if I know the mid-segment, a lot of times, to me it's easier, one calculation. You guys should be very comfortable with finding a mid-segment. This plus this divided by 2 is my mid-segment, right?
I had the right triangle, I had the area, but I just couldn't put it together.
This is a classic problem that if I know it's rotating, and this is something that geometry teaches you to think outside of the way, yeah, and oftentimes have to either, sometimes, you know, if you have to rotate your page, right, or somehow see the right triangle. Yeah, but that was all kind of contingent on. Good problem. I'm gonna go to 376. A lot of the work that you're gonna be working on are word problems involving what we've already been covering. Here's the thing, and I've even put this on the homework page. Take the time to read the problem, diagram out. If it's in a Pythagorean theorem section, there's gonna be a right triangle, okay? A lot of them are gonna involve Pythagorean triples. A lot of them are gonna involve special triangles, right? Okay? So you're either gonna use a Pythagorean, a triple, a special triangle, or it's just the Pythagorean theorem, right? One way or the other. But just trust that you have everything you need to know to get there. If you're stuck, email me. I can usually send you a hint. I can, you know, so rather than just copying solutions, right? I'd like you to get the most out of these kinds of problems, all right? Top of page 376, here's where we're integrating these problems into things that we've already seen, okay? Take a look at the first figure up at the top. First of all, it is a solid. It is a 3D figure, right? How would I find X? If I'm looking for the surface area, then I would need to know what the slant was, okay? How would I find it?
It's a triangle.
It's a triangle.
Yeah.
Is it a special triangle?
No.
Is it Pythagorean triple? So you would use the Pythagorean theorem. That's all there is to it. And again, remember, I'm a fan of calculators, but if you're asked for exact answers in simplified radical form, you're not using a calculator, all right? Unless you need to finish. So this one here would be 6 squared plus 4 squared. X is the hypotenuse, right? So we're going to say the square root of 36 plus 16, square root of what, 52?
52.
And then before you box that up, you ask yourself, is there a perfect square in there? Is it divisible by 4? Easy way to know if divisibility by 4. Take half, 26, take half again, 13. If you can take half twice, then you know that's a division. Taking half is divide by 2. Take half again, divide by 2 again. So easy way to mentally test it. So we get 2 root 13 whatever it's called.
Meter.
They're meters this time, right? Okay? All right? And that's how you would express the answer. Take a look at the middle one. That is a trapezoid. It's a right trapezoid. So this one they did give us the height because we have the perpendicular. Okay? So if I wanted to find the distance of x, how would I do that?
Right triangle on the other side.
Yeah, you just draw, notice, if I have a right angle on the left.
Is there a triple that's 15, 17?
There is.
Yeah, 8, 15,
Yep,
17,
8. Yep. So if this is 17, notice if this is 20 and this is 15, that's 15, and this is one of the 4 triples I've asked you to memorize. I've recommended that you memorize. That has to be an 8, okay? Because 8 squared plus 15 squared will equal 17 squared. Or use the Pythagorean theorem. If you forgot, you'd get 17 squared minus 15 squared, and when you calculate, run that through your calculator, what are you going to get? 8. Okay? So, sometimes you're going to see nice little
X
triples.
is 28.
Yeah.
X is 28
Meters.
meters. Thank you. 28. It's going to be 20 plus that would be, okay? There you go. Something like the third figure. It is isosceles, right? Okay. So, why do you need to know that that's isosceles? What does that
4 by
tell
2.
you?
Thingy
That's
bobber.
it.
Huh?
So you split the base.
That's how you know that you could split the base, right? Otherwise, if you didn't know that, if all you saw was this, and it wasn't marked isosceles, they might look the same, but it might not be, right? That could be slightly over one way or the other. But because they've told you the two base angles are the same, that means that that and that are the same, which means that's a 2. And now you've got the height, right? If you're looking for x, which is the same as the height, it's going to be the square root of, I want this shorter side, so this is going to be my 8 squared minus my 2 squared. Get 64 minus 4, square root of 60. Square 60 has a 4 in it. 4 times 15, 2 root 15 meters. Distance is just the Pythagorean theorem, right? Okay, so if you, for in the practice problems, I'm actually, so A to B is just a Pythagorean theorem. In fact, what is A to B? That's a 6, 8, 10 triangle. So you could do A to B would be 10, A to D will be an irrational, or not, it will not be a triple. B to D would be? B to D.
17?
17, that's the 8, 15, 17 triangle. A to C, what do I have to do to get A to C? Does anybody, if I
The
3.
do the 3D version of the Pythagorean theorem, otherwise I'd have to figure out otherwise I'd have to do A,
I mean, you already figured out AB.
you could,
No.
there's 2 steps or 1. As it turns out, I don't have to figure out that diagonal at the bottom if I know the 3D Pythagorean theorem. I'm going to mention that because it's just, you get to where you're either going to do 2 versions and add, and take one version and then input in the other, but if you have a prism, you might as well use the 3D version, which is as simple as the square root of. Do I know all 3 dimensions of my
Yeah.
prism? What are they? Well, I know it's an 8
6.
by 6 by 15, right? It is that simple. The distance will equal that. I kind of think of me, because it's usually C if it's the Pythagorean theorem, and the D is like 1 dimension further, so I have 1 extra dimension in there. And if you're using a calculator, you can get a decimal estimate, but if you want the exact answer, you're going to have to go through this process. You're going to have to square and add. If you're asked for an exact simplified answer, you can't just plug this through and put a decimal. What's the next step?
25.
There's a 25 and 325, so try factoring out the 25. That's easy enough. Times what?
13.
13? Oh, 13's prime.
5 root 8.
So it's 5 root 13. Pull the 25 out and you get 5 root 13. Whatever the units are, meters. There we go.
It's 29.
So the little divisibility rules are kind of helpful.
Pretty sure.
SB page 379. And this is the new-ish piece of it. It shouldn't feel really new because it's just the Pythagorean theorem on a coordinate plane. Here's the general idea. I'm going to talk about this without really referring to the handout for a moment, okay? I'm going to call this point A, and I'm going to call this point B, okay? If I want to know how, and this is a x, y coordinate plane. If I want to know the distance between these 2 points, unless it's a perfectly vertical line or a perfectly horizontal line, it's going to be the hypotenuse of a triangle, a right triangle. And the right triangle is going to be formed by the differences in the y's. This would be my y difference. How much does y change? And this would be how much does x change, right? This will be my change in x, this will be my change in y. If you notice, the distance formula, which is printed in every book, and it's actually at the bottom of, it's the bottom of page 379. It looks pretty hideous. They'll say it'll be something along the distance is equal to the square root of, say, x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. But what am I doing? I'm taking the distance and squaring it. And yeah, this is a squared plus b squared equals c squared. It's the Pythagorean theorem, right? So I actually never memorized this. You want to, I really don't recommend it. There's a lot of a lot of mistakes that are made using the formula. Think about it. You can think about it geometrically. It's not that hard. Let's just give some points to this. Probably close enough. Just making up some points. Okay. If you're seeing this is an x and a y, and this is an x and a y, okay? Well, how much did my x coordinate change by? 3. That means x changed by 3. That's the distance, okay? From here to here, x went from 4 to 7. You could do 7 minus 4, plug it in the formula, you will get that. The problem is you sometimes get 4 minus 7 and you get negatives, and yes, you're going to square it, but then you have to juggle negatives, okay? And our brains just don't handle negatives, especially squaring and under square roots and addition, all these other things going on. So if you can just think in terms of distance, how far apart are they? Distance doesn't care about negative or positive. Distance is what we call in physics, it's a scalar. It has a magnitude but no direction, no sign, okay? What about the y's? I made these up. So, y went from 6 to negative 4. How far apart is 6 and negative 4 on a number line? 10 units apart, right? So, y is, there it is. There's my triangle. So the distance is the Pythagorean theorem. I'm going to take the square root of 100, don't square twice, plus 9, right? 10 squared plus the square root of 109. I made this up.
That feels prime.
Huh? Could be.
You guess that?
Can't be divisible by 9. Yeah, it won't be divisible by, I think that might be a prime number. I think it is. Else it's divisible by a 7.
No,
Not
not
divisible by
divisible by
7. Not
7.
divisible by, yeah, I think it's prime.
13.
I'm keep trying to think.
Well, you wouldn't go up past 10 because,
But if they're prime numbers, you can use those.
but I know it wouldn't be anything past a 10 because
Oh, yeah.
11 is 121. So I know 11,
Oh.
12, and so on wouldn't go into that.
Yeah.
Right? If I'm looking for square number, right? So I know I only have to check up to 10, right?
Okay.
And it doesn't work for 9, doesn't work for 7, isn't any of the even numbers, if it doesn't work for 9, it won't work for 3, and so on, right?
What's the rule for 7?
There's a really convoluted and very it's easier to do long division and divide in there than to use the rule of 7.
Okay.
Even the 11 rule is a little bit convoluted.
7 is like you take the 2 last digits and then pull out a 7, and then you have to you subtract it from the other number. It's really weird.
Yeah, it's easier for me to think 7 goes into 10 with a remainder of 3, 39, 7 doesn't go into 39, I'm done. So that's
Yeah.
how I test for 7s. Okay?
Yeah.
Yeah.
And
So-
9 is the digits add up to 9.
Yeah.
Yeah. And again, if
A
it,
multiple of nine.
Or
yeah,
three.
multiple or a multiple or a multiple. So 3 is sums of digits, right? Yeah.
I'm curious if there's a way on your calculator to like see if a number is prime.
I wish. It's
Just like a function.
Somewhere.
I don't think so.
through.
because that's the whole like
The whole thing is that
Yeah.
this is the reason that primes are used for encryption is
Yeah.
because they're not predictable. So there isn't a predictable pattern. If that's a number theory idea. There's some really cool videos out there on prime numbers and number theory that's come out of those, but that's why they use prime numbers for encryption. Page 379. Okay, these are right out of your book. Here's what I want. It says graph the pair of points and find the distance. But I'm going to challenge you at this point. Do we need to draw a graph every time? I mean, it is nice. Sometimes people want to see it, but if I have, let's just say I'm given 2 points, right? And this is actually at the bottom. If I have this point and this point, it might help. Sometimes it helps if people write the X and the Y above it. If you're a visual person and this is new to you, I recommend you do that, okay? Distance, right? I actually tend to put the Y on top because I have a habit of putting slope and Y on top. So if I take the difference between my Y's, how far apart are my Y's?
-5.
Yeah. Actually, I could put -5, but I'm actually just going to put the distance of 5. Now I'm doing distance, so I don't care about the
So
sign.
exactly what that is.
And, yeah, and the X's are how far apart?
12.
12. So what I now know is I have a right triangle. One leg is 5, the other leg is 12. The vertical distance, right, is, so what does the hypotenuse have to be? 13. This is a 5, 12, 13 triangle. If I did plug it into my distance formula, I would get the distance is equal to the square root of -1 minus 11, the quantity squared, plus -2 minus -7, the quantity squared. Do you see why I don't use the formula? There's a lot, I'll get there, but it is not, there are some, and we make mistakes with negatives. So this would end up being -12 squared, I get 144, and I missed the fact I have triples, right? And this would be -2 plus 7, so this would be 5, and then I would plug that through and I'd get the square root of 169 and I'd get 13. All that work. Whereas if I do this, I see, oh, the distance of the x's, or the y's is 5, x's are 12, oh. And if these are not a triple, then plug it into the Pythagorean theorem. This is an A and a B. That's it. It's going to be, the distance is going to equal the square root of 12 squared plus 5 squared. You're going to get there, but without all those negatives. So take a look at B. Make sure you can do this. I've been weaving in some coordinate geometry from the beginning, okay? We've already been doing this. One of the homework questions today was a coordinate geometry question, right? Okay, if it helps, you can label this, right? What's my change? How far apart are my y's? I'm going to think this through geometrically. Between -6 and +10, my y distance is 16. I could do it this way, right? And between x and x, this distance here is 12. I have a 12, 16, 20 triangle if I know my triples. If I didn't, I could say, well, my distance is going to equal the square root of 12 squared plus 16 squared. And when I run that through my calculator, what's going to pop out is 20. Okay? And you'll be like, oh, I missed a triple. That's
Yeah.
okay. All right? It happens.
And then you learn the next time.
Huh?
And then
You get better and better at it
Yeah.
when that happens, right? You're like, I did all that work for nothing.
Mm-hmm.
Okay, all right. So 9.5, there is one additional idea in 9.5 that I'm going to wait until after the break to cover. That has to do with circle equations, and they're not that hard, but it's completely new to most people, and we'll deal with that after the break. If by chance a homework problem involves circle equations, skip it. We're going to do it after the break. Look at number 6. I'm just going to hop down to number 6. It says determine whether triangle DEF, is it isosceles, scalene, or equilateral? What are they asking you? Are the sides all three the same? Are two of the sides the same but one different? Or are all three sides different? How could you figure that out? Is if you knew all three distances, right? Sides of the triangle will be distances. I've written this out. I have found this to be kind of an efficient way to do this. So just look, I'm a little bit of an efficiency freak. So I'm going to write this. This is written out the way when you're, okay. And then you have F, right, is 24, 18. Okay, if I want to know the distance between D and E, I can do my little, hey, between these 2 points, right?
6.
It's the distance of 6. Between these 2 points,
33.
distance of, what is it, 33, sorry,
33,
yes. Okay, now I'm not doing slope here, be careful, I'm not, but I am doing distance. So DE, before I go any further, okay, I'm just gonna keep going here, all right? I'm gonna go, so this is, so we could say DE, right? This one's gonna be the square root of 33 squared plus 6 squared. That is not gonna be a triple, that's DE, okay? You can just keep going, okay? If I want to do EF, use a different color here. Between negative 12 and positive 18, I have a distance of 30. Between positive 39, difference distance of, what is that?
39 minus 24.
Yeah, what is that? 15, thank you. Oh, okay.
So it's 2. 15, 30.
If I was doing slope, it would be 2, but I'm not doing slope. So this one here, EF, now I'm doing distance, right? I'm gonna take the square root of 15 squared plus 30 squared, right? Okay? I'm just writing them out. If I want to do the last one, if I want FD, I could actually copy D over here. Do you guys see that? And do this and keep going. 6, negative 6. I could just do a little tree here. Okay? The distance in my Y's are between 18 and negative 6 are 24. I'm just doing distance, right? They're 24 units apart. These two are 18 units apart. So DF is going to equal the square root of 24 squared plus 18 squared, okay? So I've actually just shown like how I could set these up. Number 5, when it says find the perimeter, you're going to do the same thing, right?
Excuse me.
Sorry, thank you. That's all right. What is 33 squared plus 6?
1125.
That's 1125, and then what's this one here?
The EF is 1125.
Then they are the same.
Oh, yeah.
Just add the squares.
It's the square, it's because you're adding squares,
Yeah,
you
but
come up with
that's
different
what-
combinations.
And the other one
Yeah.
is
Okay,
900.
so this is isosceles. Once you know this, you've answered the question. It's isosceles. So that one will not be 1125, you don't even have to go any further than that. So I'm actually gonna end with 390. That's good. I have lots of words. It's gonna be the search for the triangles.
Oh.
That's all there is to it. Okay. You draw a triangle from the problem and you get there, all right? Okay, number 1 is a little like the word problem we did at the very beginning of the class. Mary and Benjamin are driving to their friend Paul's house for a birthday party. Mary drives 9 miles north and 6 miles east. Okay. Benjamin drives 3 miles south and 7 miles west. How far does Mary live from Benjamin? And let's start down here. Mary goes 9 up and 6 over, right? Okay, to get to the birthday party. There we go. I do recommend doing these in pencil. I have some people who love to do their math in ink, and I do these in pencil for exactly that reason,
Yeah.
okay?
Oh.
All right?
Did my mom
Now-
she forbid us from
I did it
This
right.
is, what's interesting about this one is since we don't know where Benjamin is starting from, we just know that wherever he starts from, he drives 3 miles south and then 7 miles west to get to the same place. To figure out where he lives, I would reverse engineer that, right? Okay? So where would his distance be? Where would he
We'll
be?
go
Over
7 more
Up
east.
7.
Right?
Wait.
So
Yeah.
from here, huh?
Just go the opposite direction of what he goes.
Down
Like
and
retrace
left.
the steps.
Okay.
Back.
I mean, sorry, backwards,
Yes,
up
sorry.
3, up 3 to the right
In
7.
order for him to go
West,
for him to go
That's
7 west,
goes like east.
east rather, he would have to be in that direction, right? So he would have to be here, and then he would also, since he
Go up
drove
3.
3 miles south, he'd have to be 3 up here. So this is where Benjamin started. This actually is a little bit tricky here, okay, right? How do I find out how far apart the two live from each other?
It's gonna be 12.
It's me 12 and
And
we're
13.
7 plus 6.
Well, it's
Okay,
12,
what I want to
13
point out
something.
to you, most people think I have to do
5
2
13.
triangles. But does everybody
Yeah,
see that I really only need to do
One.
one triangle?
3 triangles to get the wrong answer.
Yeah, exactly. Well, I mean, I could find the hypotenuse of that and the hypotenuse of that, but I don't know where that is.
Yeah, you don't.
And so, yeah,
It's if you
so
One
that's
more,
not
right?
gonna be the way to do
It's like
it.
that.
Huh?
There.
What?
So what you have is, if I was to look, yeah, you have a triangle here.
Like this. So
Yeah.
you could do those two, the hypotenuse are
Yeah.
equal to each other.
They
or
wouldn't
you
even
could
vary
just
the
do
spot.
that.
I thought you were
Hmm?
saying
Is anyone need to vary the spots, or that you know of? Like,
Have a mirror or something.
yeah.
So they're 5 apart.
Okay, so if I measure.
So how far
Okay.
apart are they?
12 and 13, so 5.
Okay,
No.
so,
No.
Hypotenuse
wait,
can't be
wait.
smaller.
this is,
Oh.
so this, so notice,
That would be.
this is
That's why I was kinda
13.
confused.
What I'm- This is 13 miles this way. How many miles is this? 9
12.
and 3,
12.
right, is 12. It's going to be a Pythagorean theorem. There is no 12, 13 something triangle, right? So this is just going to be, the distance is going to be the square root of 13 squared plus 12 squared. And this one, you it didn't say simplified radical, round to the 10th means, crank it through the calculator.
17.7.
Huh?
17.7.
About 17. And that sounds about right.
Yeah.
Miles apart, right? Okay, and of course the triangle, it should make sense. The number should make sense. Okay. I don't know what the radical under there was, but you wouldn't say something along the lines of, yeah, they're 5 times root 13 miles apart. You would never say something like that to somebody, right? We want to put a number that somebody could.
They might want to
Yeah.
Let's do the second set here. Televisions are sold based on the length diagonally across the screen. Widescreen televisions have an aspect ratio of 16:9. Do you guys know? Have you ever realized if you're watching some kind of streaming show that the older TV shows that the sides don't exist because we didn't used to have these widescreen, right? So that aspect ratio. My husband's in this business, and even projectors have to be programmed and set certain ways, right? So if you notice, if it's 16:9, okay, what that means is that's the ratio of the height to the length, right? Okay, so let's just say that's 16:9, and it could times something, right? You'd have to say there's some. That's the proportions, okay. But when we talk about if you buy a 72-inch TV, it's not this. It's the diagonal. So whenever we say 72-inch TV or this or that, it's going to be the diagonal length, right? So it says, what are the length and width of a 45-inch widescreen television? Well, if it says 45-inch, which now by today's standards is going to be small-ish, right? What we're talking about is, in order to come up, we've got 9 times 16, right, if you will. There's my triangle.
Plug it into an equation, solve for x.
Yeah, you could. Notice, I'm going to get, I don't know if I did it this way. 81x squared plus...
Or 9x squared, which is 81x squared.
Yeah.
Oh,
Well, that's all right.
okay, I thought.
And then I think this is 256x squared is equal to 45 squared, right? I could look at it that way. I don't think it's going to be a
Oh.
If this
Because
was,
it's 60
you can't factor a common factor out of that. If that was a 12, I could have, right? Wishful thinking. Anyway, these two combined, right? I could combine these with 81 and 256.
337.
Right? So I'm gonna get 337x squared is equal to 45 squared. Divide that by 337 and take the square root. I'm going to get the x. About, is x equal to, yeah, you could say, so if x is about 2.45, then 9 times that would give me a dimension. What would it be? That's why these are not gonna be standard inches.
About 22.
About 22, is that right? Yep, that's about what I got. I think I even got 22.1, and this would be about
Oh yeah, 22.
39.2. Okay? That's why some people get a little disappointed when they say they're 45-inch TV, but it's only 39 across, right? 39 by 22. It's the diagonal. Makes it seem bigger than it really is, okay? But a little bit challenging. What was nice is I didn't really have any quadratic theory here because I could just solve with a square root, right? Okay? And then number 3, a ladder problem. Whenever you have ladder problems, assuming that building is perpendicular to the ground, the ladder is the hypotenuse of a right triangle, right? Okay? So he's got 2 ladders that are set up to clean the gutters of his house. The top of each ladder reaches the base of the gutter 30 feet from the ground, okay? By the way, that last problem, I'm looking at my solution. The way we did it perfectly fine, I actually used a proportion. I used x just to say that anyway, it's probably about the same amount of work. Okay, so in this case, we're saying that the top of each ladder reaches the base of the gutter 30 feet from the ground. One of the ladders is 32 feet, the other 33. If the tops of the ladders are 20 feet apart, how far apart are the bottoms of the ladders? Huh?
I thought the tops were the same part, both at the gutter.
They're both, okay, here, I'm gonna draw the 2 triangles. So I'm gonna draw 2 triangles here, okay? They're both 30 feet high, okay? And one ladder is 32 feet. The other one, right, it's gonna be 30 feet high, but it's 33 feet, okay?
But why does it say the tops are 20 feet apart?
That's going to come into play in a minute.
Okay.
This is actually far more complicated than it looks.
It's 30 feet from the ground.
So this one you actually have to think some 3D. I'm gonna draw a rectangle in a moment, but I do need to know these 2 distances.
Oh.
Okay. This is not as easy as it looks. Okay. I need to know these 2 distances. Let's just put them in decimals. If you crank this through the 32 squared minus 30 squared, take the square root, crank through the Pythagorean theorem, I'm going to get about 11 point, say, 14. And these are feet, about, okay? I'm going to rush a little bit because it's just turning 2 o'clock right now. This one here, running through the Pythagorean theorem, 13.7 feet, about. Okay, this is what makes this problem rather devilishly, okay, if you think about it. Let's say that's the base of the building, right? Okay, so this is the building. They're 20 feet apart, right? One ladder's leaning this way. The base of one ladder is this 11.14. The base of the other ladder is the 13.7. In other words, if I'm from the top down looking down at the bottom, at the ground, right? Okay? And it's asking you how far apart is this segment? Mm-hmm.
About
So it's just like-
20.17? 20.2?
Yeah, nice job. So what did you do to do that? You make a rectangle, right?
I subtracted the 13.7 to 11.
So what is this little bit?
2.6.
2.6 feet, right? So now I have a 2.6 and 20, the square
that's
root
just-
of 20, thank goodness for calculators.
Yeah, no kidding.
Squared is about It should be
Yeah.
longer than 20,
20.2.
and it turns out it is about 20.2. Not a whole lot longer,
Yeah, because 2.6 is relatively small
about
compared to 20,
20.2
so.
feet. Okay? So don't get too scared. I think every kind of problem that we've done here, the next set of the problems are very similar to this. I have recorded these. Draw diagrams, draw triangles, do the best you can. If you really can't figure it out, email me for a hint, and you will have the solutions too. Just understand, just trust that you do have everything, you do know everything to solve these, but 2 or 3 of these can take a little bit of time. That's it.